All right, so number 14 here, Tammy and Keith each work 2 part-time jobs in the summer, mowing lawns and raking yards. Tammy earns $10 for each lawn she mows, $5 for each yard she rakes. All right, she wants to earn more than $200 from her part-time job. Keith, $12 for lawns for mowing, $3 for raking. He wants to earn more than $180. Write a system of linear inequalities, all right, to show this. We don't have to solve anything. We just have to write it. Okay, so first let's talk about Tammy. Okay, so Tammy's equation is going to be 10x for mowing plus 5y for raking, and she wants to earn more than 200. Okay, and then we have Keith's equation, all right, or inequality, excuse me, which is going to be 12x for mowing and 3y for raking, and Keith wants more than $180. That would be their systems of equations. Just be careful, you know, on the keystone like this, if you do write an answer up here, but they're giving you an answer space, you would want to make sure that you write the answer in the space that they provide for you, okay? We want to make sure we're going to get full credit for everything, so just be careful with some of those small details. By the end of the summer, Tammy and Keith both have mowed the same number of lawns and raked the same number of lawns. So that means their x and y coordinate here is going to be equal. We need to know what that coordinate is to show that Keith met his goal, but Tammy did not. All right, so I'm actually going to do this a little bit differently. I'm not going to do this algebraically. I'm going to use this graphically, okay? And what I want to do is take each of their equations, or excuse me, their inequalities, jot those down here from earlier, okay? And I'm going to make a little table for each of them, okay? So Tammy's table is going to look like this. All right, so if I plug 0 in for x, what would I get for y? I would get 40. And if I plug 0 in for y, I would get 20 for x. That would be Tammy's table. Okay, Keith's table is going to look like this. All right, so if I plug 0 in for x for Keith, I'm going to get 60. And if I plug 0 in for y for Keith, I'm going to get, let's see, what is that? 180 divided by 12. That was 15. 15 for Keith. All right, so I'm going to make a little graph here, okay? And my graph needs to go all the way to, what, 40 on the, let's see, on the x-axis it has to go to 20, on the y-axis it has to go to 60. Okay, so let's just make a little grid here. All right. Let's see here. If I count by 5, this should be good. 5, 10, 15, 20. And I could probably actually even count by 10s over here because I'm not plotting anything y. All right, so that would be 10, 20, 30, oops, 40, 50, and 60. Okay, so if I grab each of their inequalities here and see what that looks like, then I'm going to be able to describe for you where we're looking for our solutions. All right, so Tammy here goes from 0, 40 to 20, 0. All right, so that would be Tammy's line. And again, these are greater thans, okay? So we'd be shading above that line for Tammy. Okay, best we can here. All right. Okay, and then Keith's line goes from 0, 60 to 15, 0. Okay, and above the line for Keith as well. All right, because remember, they want to earn more than this amount that they have listed there. Okay, so what we need to pay attention to here or understand here is that in the problem it says that Keith meets his goal, but Tammy does not. So when we think about the regions that are on this final graph, okay, this area right here would be the area where both of them met their goal, okay? The red one only would be where Tammy met her goal but not Keith, and the blue one only will be where Keith met his goal but not Tammy. So we're trying to choose a value that's in that region there for Keith only, okay? And then we can test it in our inequalities just to make sure, all right? But it looks to me like if I went 5, okay, for y, which would be raking, and any number between 15 and 20 there looks like could work. So let's just say 16, all right, to be sure that I would So 16 mowed lawns and 5 raked lawns should work. If you really want to be careful and double check this, then you would plug that in for each of those inequalities. So 10 times 16 plus 5 times 5. Okay, that should not work. That should not be greater than 200 because that's Tammy's. All right, so that's 160 and 25, which is 185. So that's true. Okay, it doesn't work for Tammy, which is what we thought. And then if we do Keith, which would be 12 times 16 plus 3 times 5. Okay, has to be greater than 180. All right, so that would be what? 192 plus 15 is definitely going to be more than 180 because the 192 already is. So 16 lawns mowed and 5 lawns raked. Now, obviously, there is a slew of answers here because anything in this region where your x's are equal and your y's are equal is going to work. Okay, so anything in there, multiple answers would be okay for this problem.